This video will cover reflections in geometry, where a reflection is a flip over a point or a line. And when we think of reflections, we want to make a mirror image. There are many rules for the reflections in geometry. You can memorize them, but we're also going to talk about how to do them graphically, as I think that's the most reliable option, because sometimes our brains just don't remember the rules because they're so specific and there's so many of them. So we're going to look at the basic reflections example here in number 1. And we're not even going to pay attention to the rules at the top. We're just going to talk about it graphically, and then we'll see if we can discover the rule based on it. So we're first given triangle MNO with M at 3, 3. So I'm just going over to the X and up to the Y. Remember, points are listed as X, comma, Y. So here's M. N is over at 5, 2, over 5, up 2. And O is at 4, 4. So we got this little tiny triangle. And our purpose here is to first reflect it over the y-axis. So it's important that we remember that axes are labeled as x going horizontally and y going vertically. So I want to take this figure and create a mirror image across this y-axis. So all I have to do here is count boxes. For example, M is 3 boxes away from the y-axis, so I'm going to count the same number beyond it and then plot a point and call this M prime. I'm going to do the same thing for N and O. N is 5 boxes away. 1, 2, 3, 4, 5. So I'm going to count 5 beyond it. 1, 2, 3, 4, 5. And it lands me here. N prime. O is 4 away. So I'm going 4 beyond the y-axis. We call that O prime. So then I have to list the coordinates. M prime is at -3, +3, N prime, -5, +2, and O prime, -4, +4. And as I mentioned earlier, we will be able to see the rule that comes when we reflect over the y-axis. So if I'm looking at my original point M and my new point M prime, I notice that the x goes from positive to a negative. And the y stays +3 and it's the same. So it looks like we're taking the x's and negating them and taking the y's and keeping them the same when we reflect over the reflect over the y-axis. In my next question, I'm asked to reflect over the x-axis. So I'm going back to my original triangle, MNO, and I'm trying this time to reflect it over the horizontal x-axis. So again, I'm just counting boxes. M is 1, 2, 3 boxes away, so I go 3 beyond my x-axis and plot a point. I'm going to call this M double prime. O is 4 boxes away, so I go 4 beyond the x-axis and call it O double prime. And N is just 2 away, so I go again 2 beyond it for N double prime. And then I just list my coordinates. M double prime is at +3, -3. N double prime is at +5, -2. And O double prime is at +4, -4. So again, we're done with this example, but if we want to look at the rule for reflection over the x-axis, and again I focus on my original point M and my new point M double prime, I see that the coordinates x, y map onto, well, I go from a +3 again to a +3 for x's, so x stays the same, and then the y's go from +3 to -3, so it looks as though we're negating y. And we could test that for the other points, such as N to N double prime and O to O double prime. But the rule, as we can see for reflection over the x-axis, is to keep the x and negate the y. If we look back at the rule for the y-axis, we keep the y, but negate the x. So you keep whatever you're reflecting over and you negate the other part. If we look down here to part C and D, we're using that same triangle MNO, so I'm just going to take a second and plot it on both pictures, and then we'll come back and talk about it. So I would like for you to do the same. Pause the video, plot M and O on both part C and part D. So at this point you should have plotted both M and O on picture C and picture D like I have here. So we're going to take this first one in part C and reflect triangle MNO over the line x equals 1. And if I think about the line x equals 1, I go and find x equals 1 on my graph, and then I'm just making that line go vertical, straight up and down, all along where x could be 1 or is positive 1. Whoops. Our next step is to just reflect it over that purple line. So just like I reflect over the x-axis or the y-axis, I'm just counting boxes. So for example, M is 2 boxes away from my line x equals 1. So then I have to go 2 beyond it, and I fall here for M prime. Next, I take N, and I'm 4 squares away, or 4 boxes away, so I go 4 beyond the line x equals 1 on the left. 1, 2, 3, 4. Again, N prime. And now I go 3 away because O is 3 away to get O prime. So M prime is listed at -1, +3. N prime is listed or plotted at -3, +2. And O prime is at -2, +5. Unfortunately, there's not a rule here, so I think using the graph is the best option. And we'll see that again here in example D, where we have the line y equals -2 that we're reflecting over. So again, when we think of where y is -2, I'm going down on my graph 2, and then I'm drawing in that horizontal line. So now I'll take each point of triangle MNO and reflect it over the line y equals -2. So again, we're just using that trick of counting boxes. How many squares is M away from the line y equals -2? And then once I find that out, I'm just going to count the same number beyond it. So M is 1, 2, 3, 4, 5 away, so I go 5 beyond. 1, 2, 3, 4, 5. M prime. N is 1, 2, 3, 4 away, so I go 4 beyond it. Oops. N prime. And O is 1, 2, 3, 4, 5, 6. It looks like this one might go off the graph, but that's okay. I'm just 1 square beyond it, so it's not too hard, too difficult to think about it when I'm counting. So I have M prime is listed or located at +3, negative, I think it's 7. 1, 2, 3, 4, 5, 6, 7. Yep. N prime is over at 5, -6, and O prime is at 4, -8. Like I said, there's no rule when we're reflecting over a line that's vertical or horizontal, with the exception of those x and y axes. But here, all you're doing is just counting boxes, so it's really handy if you can either sketch yourself some graph paper or you have graph paper by your side to do this with. One more thing that I want to talk about that's going to be in your practice is reflecting over the line y equals x. And that's this line that goes through the origin and has a slope of 1 over 1. And so here, if we were to reflect over that, there's a way to do it graphically, but the rule is very easy. Your reflection over y equals x actually gives you the rule right there. We're going to take x comma y and map it onto y comma x. And like I said, the rule is right there in this reflection. They want you to put y first and x second. So all you're doing is switching the spots of x and y. Our last example with basic reflections is the reflection over the origin. So again, we're sticking with that triangle MNO, so take a second, pause the video, and plot triangle MNO. Now that we have triangle MNO plotted, we need to reflect through the origin. The rule for this is very simple. You take x comma y and you map it onto -x, -y. So we can find out the coordinates by doing this, I guess, beforehand and then plotting them afterwards, but we can also talk about how to do them on the graph. So I'm just going to list the coordinates first, and then we can plot them after. So I take +3, +3, and negate both. So it becomes -3, -3. I take +5, 2, and it becomes -5, -2. Again, just negating both x and y. and O prime would now be at negative 4, negative 4. So I could simply just go and plot these now, but I want to talk to you about how to find it graphically. So if I take M and I want to reflect through the origin, that's that point 0, 0. I need to see how far M is away from that point. So I'm going down 3 over 3. So now I'm going to do just the opposite. Over 3, down 3. And that leaves me with M prime. And you can see that it's located at negative 3, negative 3, just like we thought that it should be. So now for N, I go down 2 over 5. So now I'm going over 5, down 2. And N prime is located now at negative 5, negative 2, just like we thought. And last but not least, I have O prime, down 4, over 4. So now I go over 4, down 4. Of course, you don't have to draw these lines on there. I'm just showing you because I'm not right in front of you. You could certainly do it in pencil if you want to, but again, you don't have to draw these lines on here. And O prime, of course, is located at negative 4, negative 4, just like we thought. So you can either do it where you do the coordinates first and then plot, or you can do it graphically using those lines that I showed you. So here we're asked the question, what properties remain invariant? And just a reminder, invariant means stays the same. So in a reflection, what properties stay the same? Well, the first thing that we need to talk about is the size, or the distance, or the length. All of them are talking about the same exact thing. It stayed the same size. Another thing is angle measure. When we think about reflection over a line, so say I want to reflect this triangle ABC over the y-axis here, it would become A, C, B, all of those being primes, of course. So if I'm looking at the orientation, I have A and I go clockwise would give me triangle ABC. If I again start with A prime this time, going clockwise, I now have triangle A prime, C prime, B prime. And you can see that the order of the letters is not the same. So when we're talking about what properties change, orientation changes. Only in a line reflection though. If I go back to the one we just did, the reflection through the origin, and I read my letters, starting on the original triangle, going clockwise, I have triangle MON. And if I go clockwise, starting on M prime, I have M prime, O prime, N prime. So those are in the same order. So if you want to put orientation on the left here for a point reflection, you can. So it's important to recognize here that because the size stayed the same, reflection, no matter what type, line or point, is a rigid motion. And this is just because it preserves distance. Now, because a line reflection does not preserve orientation, a line reflection is an opposite isometry. So again, because it did not preserve orientation, it's an opposite isometry. And isometry is just another word for rigid motion, preserves distance. If we look down here at example 2 where we're asked to work backwards, it tells us that the graph shows triangle A prime, B prime, C prime, the image of ABC after it was reflected in the y-axis. Graph and label triangle ABC. So I have to reflect it back over the y-axis in order to get the original picture. So all I'm doing is counting my boxes again. I see that A prime is 2 away, so I go 2 beyond. B prime is 5 away, so I go 5 beyond. And C prime is 4, so I go 4 on the other side. Oops, and I'm labeling these with primes when I should just be labeling them with their original letters, A, B, C. Because remember, the primes are already plotted for us and we were going backwards. I'm just going to quickly list the coordinates of A, B, C, and I'd like for you to pause the video and do the same. So now that we have these coordinates of A, B, C, I can now graph and label A prime, A double prime, B double prime, C double prime, the image of A prime, B prime, C prime after it's reflected in the origin. So I'm going to take this and I'm going to do it graphically just as I showed you just above. And I have C prime is down 1 over 4, so I'm going over 4 down 1. And I've got C double prime here. And now A is down 5 over 2, so I'm going over 2 down 5. 1, 2, 3, 4, 5. A double prime. And B prime is down 6 over 5. So again, over 5, down 6. I'd like for you to again pause the video so that we can list the coordinates for the double primes. A double prime, B double prime, C double prime. And now our last and final step is to state a single transformation that will map triangle ABC, the original triangle, onto A double prime, B double prime, C double prime. And this is the reason that I wanted to list the coordinates, but also have it graphically, because you can see what's happening to go from the original triangle in orange to the double prime triangle in pink. It looks as though I'm reflecting over the x-axis. So here I'm going to say reflection over x-axis. And if you choose to write that out in the notation, remember that it's a lowercase r, and then x-axis is written as subscript. Either of these would be acceptable for your answer. And again, if we just look at the coordinates themselves, the actual plotted points listed out as -2, +5, and -2, -5, I notice that I'm taking x, y, my originals, and mapping it onto x, -y. So if I keep x, that means I'm reflecting over x. At this point in time, you've got 2 pages of practice problems to do. If you need to go back and rewind, please do so. Otherwise, keep moving forward.